In progress.
Oh my God. Okay, so for today, we are on page 26. Page 26. And I want to go through just a handful of different problems from what we've seen so far in our little factoring journey here. So your last notes video, your last piece of the homework was a video on factoring trinomials, things with 3 terms. So we're going to see those mixed in with some GCF and grouping stuff for today. As a reminder, anytime that we are factoring, the very first thing I want to do is check for GCF. I want to see, is there something that I could factor out of all of these terms? And if there is, I want to pull that out to start. On the last assignment that you guys did, you saw for a few problems, we had our factored form, and then one of our factors maybe still had a GCF in it that we could pull out at the end. So our goal is generally to, if we can, avoid having GCFs to remember to pull out at the end and try and get them at the beginning. So for each of these problems, the very first thing we want to look for is there a GCF for me to factor out? So for number 1, do I have a GCF, a greatest common factor, to take out here? Can I divide all of these by something interesting, something besides 1? No, they don't all have X. They're not all divisible by the same number. No GCF here. So we're going to use one of our trinomial strategies. So in the video, you saw AC method and you saw something that we'll call guess and check. Okay. I will primarily use AC method when we have a lead coefficient that is not 1. That's when I will use AC method. You can always use AC method if you would like. Your A value here would be 1. So 1 times 14 is 14, and you would look for factors of 14 that add to 9. I skip that step when our lead coefficient is 1. So I'm just looking for factors of C that add to B. So what would multiply to get me 14, but add to 9? If you ever get stuck, you can always make a list. So I always go in order. So this would be 1 times 14, or -1 times -14. And then the only other option is 2 times 7, or -2 times -7. So if you get stuck, make a list. Okay. We want 2 times 7. For some people, it's like it's already printed on their paper for them. That's how quickly they think of those factors. For some of us, we need to make a list. It takes a little bit longer to think through all the options, and that is okay. So 2 and 7. And then again, since our lead coefficient is 1, we can hop straight to our factored form, which would be x plus 2, since this is a positive 2, times x plus 7, since I've got a positive 7 there. Remember that you can always check your factoring by multiplying it back together. So I'm going to do that just on this first one. If I were to multiply this back together, x times x gets me x squared plus 7x plus 2x plus 14. If I combine like terms in the middle, 7x and 2x is 9x. So I would have x squared plus 9x plus 14. Okay, back to my original problem. If I distribute, I should get the original problem back. Okay, now what I want here is the factored form. So this is my answer, just so we're clear. That factored form is what I want. But again, you can always check your work on this. Now let's take a look at number 2. Start by looking for a GCF. Do I have a greatest common factor I can pull out of all of these terms? GCF here? No GCF here. I cannot divide all of these by anything besides 1. So since it's in 3 terms, I'm going to look at one of our new strategies, either AC or guess and check. If you are a diehard AC method person and that is what works for you, you like to be able to do the same process every single time, then absolutely do AC method on problems like 1 and 2. I'm gonna, where I can, speed up our work just a little bit for today. So since our lead coefficient is 1, I could use that guess and check method here. So that means I want factors of C that add to B. So factors of 28 that would add to -16. Since I want to add to a negative number, that's a hint that I'm going to want to pick negative factors. Okay. Number 1, we were adding to a positive number. So even though I listed the negatives, we knew we needed positives. Anybody know what factors we want? Factors of 28. So what multiplies to 28? It would add to -16. -2 and -14 would do it. Okay. So then my factored form would be x minus 2 times x minus 14. Now, if you thought of these in the opposite order, you thought of this as -14 times -2, and so you have your factors swapped, that's okay. As long as you have the same stuff in parentheses, if you've got a swapped order, that's okay. Let's take a look at number 3 now. Again, I want to start by identifying a greatest common factor if we have one. So do we have a GCF here? What do we have? 2. And do you guys remember when we were doing our grouping stuff, I said if your thing starts with a negative, pull out a negative? Does that sound vaguely familiar last week? So notice how we actually have -2 in front here. Let's go ahead and pull out -2. If I just factor out +2, we would still have -1 left here, which means we're forced sort of into AC method here. So I'm going to go ahead and pull out -2. So that would leave me with x squared minus 17x plus 144 divided by 2 would be 72. Careful with your signs. Notice they changed here because I'm dividing by -2. And now that I've got, excuse me, now that I've got my GCF pulled out, our lead coefficient for what's left over is just 1. So we can use our guess and check method here again. So I want factors of 72. That would add to -17. So what would multiply to give me 72, but add to give me -17? -9 times -8. Perfect. Oops, running out of space there. So this factored form would be y equals -2 times x minus 9 times x minus 8. Perfect. Let's take a look at number 4. Do I have a GCF I can pull out on number 4? No, not everything has an x. 3 and 17 and 10 don't have any common factors. Since I have a lead coefficient this time that is not 1, I'm going to use AC method. Now, it is possible to do guess and check on a problem where the lead coefficient is not 1, but it generally takes us a little bit more time. There's a lot of called guess and check, so guessing and checking. You have to distribute to check to see if the factored form that you've tried is correct. So I'm going to steer you towards the AC method on a problem like number 4. So that means I'm going to take my A value and multiply by my C value. So 3 times 10 gives us 30. Watch your signs on AC method. And I want factors of 30 that would add to 17. So what would multiply to give me 30, but add to give me 17? 2 times 15. Okay. Now here's the other part where AC method is a little different. The first thing that's different is A times C. The second thing that's different is I cannot jump straight into my factored form. Remember, whatever your factors are, we should be able to multiply back together to get our original problem. If I just did x plus 2 and x plus 15, when I distribute back, that x times x would give me x squared, but I wouldn't have the 3. Okay, so I have to have something in front of x in at least one of my factors. So to figure out how that should look, what we're going to do is replace the middle term by splitting it up using the factors that we've chosen. So we're going to keep the first term, 3x squared, and then plus 2x plus 15x plus 10. The only thing that changes is the middle, and we change it by splitting it up into the factors that we've chosen. The order of those factors does not matter. So if you did 15 times 2 and you put the 15 first, that's okay. You'll still get a correct factored form. Now we've got something with 4 terms that we can factor by grouping. So that's what we'll do. We'll split this up and do 2 terms and 2 terms, and then we'll look for the GCF for each group. Okay. The idea behind AC method is I take something that I'm not quite sure how to factor that's in 3 terms, and I rewrite it in a way that I've done before. We've done factoring over things with 4 terms before. We've done factoring by grouping before. So we're relying on that old skill to help us do a new thing. Okay. So my GCF for this first group would be x. When I factor that out, I'm left with 3x plus 2. The GCF for my next group would be 5, positive 5. When I factor that out, we'd be left with 3x plus 2. My stuff in parentheses is the same, so I'm going to pull that out in front as my GCF, 3x plus 2. And then the stuff in front is what makes my other factor, x plus 5. There's my factored form. 3x plus 2 times x plus 5. Now, if you had swapped your 2 and your 15, this in-between step would look different, but you would end up with the same final factors. Let's take a look at number 6. Number 6, same idea. Start by looking for a GCF. So do I have a GCF here for number 6? For greatest common factor? No. So since my lead coefficient is not 1, I'm going to use AC method. So 5 times 2 gives me 10. And I want factors of 10 that would add to negative 7. Factors of 10 that add to negative 7. Negative 2 times negative 5 will do it. And then I'm going to pop these in for the middle term. I'm going to split up that middle term using the factors that we chose. So this is 5x squared minus 2x minus 5x plus 2. And then I'm going to factor by grouping. Again, if you have the middle numbers swapped, that's okay. Your next line will look different, but your final factors will be the same. The GCF for my first group would be what? What do these have in common? X. So when I factor out x, I'm left with 5x minus 2. How about my next group? What's my GCF there? 1, and since the group starts with a negative, we'll do negative 1 because that will change the sign. So now this is positive 5x minus 2. And once I change the signs, my stuff in parentheses is the same. So that can come out 5x minus 2. And then my other factor would be what's left over. So x minus 1. Again, be careful with your signs. Questions for me so far? Okay. So we've done a few problems over the new stuff. Just as a quick refresher, I want to do a couple problems that are a little bit older material. So remember, we always start by looking for a GCF. Do I have a GCF in number 11? What can I divide out of both of these? 2. So that would leave me with 4x squared minus 9. At this point, we don't know how to tackle the thing in parentheses just yet. That will be something we get to a little bit later this week in one of our upcoming lessons. So since this is in 2 terms, I don't know how to work with that just yet. We're going to leave it right there. And let's take a look at number 13. Do I have a GCF, a greatest common factor, for number 13? Something I can divide out of all of those terms? Nope. So since it's in 4 terms, we'll use grouping. What's my GCF for the first group? X squared. That would leave me with 4x plus 1. What's my GCF for the second group? 2. So I'm going to factor out a 2. That would leave me with 4x plus 1. My stuff in parentheses is the same, so that comes out front, 4x plus 1. And then my other factor is what's left over, x squared plus 2. There's my factored form. One more I want to take a look at together for today. Number 19 in that bottom row on page 26. Is there a GCF here? Nope. So since it's in 4 terms, we're going to split it up into groups, and I need to know the GCF for my first group. Five x squared. So left over, I would have x minus 2. How about my second group? What's the GCF there? 3, positive 3. When I divide 3 out of here, I'm left with x minus 2. Stuff in parentheses is the same, so that comes out front. And then left over, I've got 5x squared plus 3. Okay, so a little refresher over everything that you guys have seen so far. GCF and grouping we saw a little while ago, and then the 3-term things, AC method and guess and check, would be our newer strategies.